Hello, hello. Tracy, can you hear me?
Yes, I can hear you.
Good morning. How are you?
Can you hear me?
Yep, I can hear you just fine.
Okay, good.
I'm going to give it just a couple more minutes. I don't know how many people are planning on showing up, so um, I'll give it till about 12:05 and then we'll get started, okay?
Okay, sounds good.
Okay. And I'm sorry, just so I can verify for attendance, you're from Canyon Valley High School?
Correct.
Okay, thank you.
hmm
Okay, I'm going to go ahead and get started. So I noticed that you have never been part of a Spark event before, at least according to your registration. So I'll just kind of go over how the sessions work, and then if you have any questions, feel free to ask them. And as we go through it, if you have any questions, since you're the only person attending right now, it looks like we have 2 people viewing, but they're not participating. So um, you'll pretty much be the only one asking questions, I think. And then we'll get started. Is that cool?
Yep.
Okay, so first off, the teacher training sessions, just in general, since this is the first teacher training session, what's going to happen is we're going to do teacher training sessions, as you saw on the website on the calendar, for the next 4 weeks. Each week, every session is the same session. So since you're attending this session, you're not going to need to attend the one on Thursday, but you're more than welcome to if you want to. I do record all of the sessions, so this one right now, you can tell it's live right now. It'll go up on YouTube and we'll change the link. So if you have any questions or want to recap on something that we went over, you can go ahead and do that. Essentially what we do in the teacher training is I'm going to walk you today through a really quick app using this program. So to follow along, what you'll need to do is go to scratch.mit.edu. And I highly recommend that you follow along, but it's not required as long as, again, you have the time to do it later. But essentially what we're going to do today is we're going to go over the main Scratch interface and kind of introduce a few of the different pieces on it. And then we're going to make a quick paint program. So you'll be able to use the mouse cursor to kind of draw on the screen. And that's typically kind of the first app introduction that we give to students. And then next week, we'll make a little game. So you'll kind of see the same format, but just as a different target. And then the third and fourth weeks, we go over things like design and specific cases that your students will need to know and that you'll need to know during the competition. We don't typically publicize the theme of the competition until the day of, but if you follow along with the teacher training sessions in those little sections, then you should at least have a good grasp of how to work with the theme when it comes time for the event. Sounds good?
Yep, sounds good.
Okay, have you ever used Scratch before, or have you ever done any programming before?
I have. I've worked in Construct 2, and I was a part of the AMP program.
Okay.
And so we did some programming in processing.org.
Okay, great. This should actually be pretty simple then. The main things are just going to be the interface. So let me go over the interface really quick. It's not too difficult, but it takes a little bit of getting used to, since if you've already got some of those other concepts out of the way, this might be a little bit different. But basically the window is split up into 4 different sections, as you can see. The first one, where we've got this cat kind of hanging out here, this is called the stage. And essentially the way that I like to kind of compare it to other things is it's like your preview window or your compiler. So whatever you end up actually coding is going to show up here in this window. Typically when you actually run these games or apps afterwards, this is the only window that shows up. So your focus kind of for the end result is the stage up here. The next section is the sprites window down here at the bottom. And this I like to refer to as like our objects window. Every single object or thing that's going to be in our app or in our game is going to show up in this section. And we'll kind of dive into this as we start making the different pieces of our apps and games. But suffice it to say, just to begin with, the big thing is that you can add new objects to your project by clicking on these icons here. You can also change the background of your entire stage here using these icons down at the bottom. And we'll do that as we actually get into our app. But for now, it's good to kind of know where those are. The next section here is this kind of strip down the middle. These are our scripts, which is the one, this tab here, we're going to use the majority of the time. And this is all the different like blocks of our recipes that we use to kind of string together our code. So in a normal programming language, you would actually type the stuff out. This is just kind of a drag and drop method, which makes it really easy for the students. But there are some pretty intense programming concepts that are present in here. So you have things like your loops, your branches. There's all kinds of different sensing that you can do, which again we'll cover in a little bit. You've got operators, so you can do all kinds of different math operations, and then you can also create your own functions or your own blocks in here. We're minimally going to use these next 2 tabs, but these are basically what each object looks like or what the background looks like. And then the sounds are what that object sounds like. You can trigger sounds, you can have them play in a loop, you can have music playing in the background, things of that nature. So as we get into the games, more than likely, we'll be touching on these tabs. Today, we're only going to use the scripts tab. And then the last section is the area right here, which we call our workspace. And the workspace is basically just where you go to drag the actual blocks that you're going to use. So as we get into making our apps and our games, you can test out these blocks by double clicking on them, and they'll do whatever the actual block action is. But once you're ready to actually put them into your app or game, we're going to drag them into this section to kind of build our blocks of code and build our code base here. So just to get started, the first thing that we'll need to do, and that you pretty much need to do for any app or game in Scratch, is you'll need one of these blocks that says when green flag clicked. And this event block is basically just telling the app to do this set of things when you click this green flag here. The green is obviously the go button, the red is the stop button. So when you press the green button, these are the instructions that you're going to run. So if I drag that into here and then put some instructions down on that, when I click the flag, it runs the app. So pretty self-explanatory, pretty basic. It'll hopefully make a lot of sense once we start dragging blocks, if it doesn't already. But as far as the interface goes, do you have any immediate questions?
No, it's all good.
Okay. So I would say today we're going to do something very targeted. Like I said, we're going to make a little paint app. I'm going to go over some of these block categories, but not all of them. But I definitely recommend, if you can show up for both sessions this week, obviously practice in the meantime, play around with it, see what stuff you can and can't do, what stuff makes sense, what stuff doesn't, and then just bring your questions on Thursday and I'll be more than happy to answer them. We typically have a good mix of beginners and people who have already attended sessions from week to week. So, you know, it's helpful, I think, for people who aren't able to attend the earlier sessions if, you know, we kind of think up of problems and questions for them. I also intentionally will be putting some mistakes into the program that we're making. I won't leave you with those mistakes. We'll fix them before the end of each session, but just in the interest of some common situations that people get into with debugging, and especially just kind of understanding how Scratch works, I intentionally put some things in here that kind of make sense at first glance, but then when we actually run the program, they're not going to work exactly the way that you might expect them to. And then I'll explain why they don't work that way and just some of those little gotchas that Scratch has. And I find that that's typically where students get hung up the most. So during our competitions, when the students are working on their projects, it's good to know some of those gotchas, because it'll just kind of help you quickly identify some of the problems that the students are having. So if you see something that, you know, I'm doing wrong or whatever, feel free to point it out, but just know that there will be some intentional mistakes in the lessons and the presentations, okay?
Okay.
All right, so we're going to start off first just by doing some very basic motion with our character here. There's a few tabs that we're going to be using today. One is the motion tab, the other is the looks tab, and then we're going to jump into the pen section and some of these events and control sections. Okay, so the first thing I want to talk about is what happens when you click the green flag. So I'm going to just make our little cat, Scratch the Cat here, jump around on the screen, and he'll kind of walk around the screen, or at least he should walk around the screen, but you'll see kind of some of the steps that we put together. So the first thing I'm going to do is drag in a move block. And when you drag in a move block, all that does is that moves the character in whatever direction he's currently facing, or whatever direction that object is facing. And it moves it 10 steps to the right. And a step is typically just like the number of pixels that they move to the right. But we can also rotate our character. So if I double click on this, the character will rotate around. And then if I double click this one, it'll rotate in the other direction. Okay. So if I want to make my character kind of walk in a square, I'll need to put together a few of these blocks. The first one I'm going to start off with is I'm going to drag Scratch the Cat kind of wherever I want him on the screen. So I'm going to start him kind of up here. And you'll notice that as you drag the character around, there's several different spots on the screen where numbers update. So you'll notice that as I'm dragging him around, these numbers down here change wherever the mouse is. But you'll also notice that the actual blocks themselves here, these XY coordinates, change. So this is a really easy way to see where your character is on the screen. And it's pretty simple to understand, but essentially 0, 0 is the XY coordinate here right in the middle. So if I go here and I want something to be in the dead center, then the coordinates are 0, 0. And our X coordinates go from negative 240 all the way to positive 240. And then from top to bottom, it goes positive 180 at the top to negative 180 at the bottom. So when we're trying to position stuff on the screen or figure out how to move it, we're going to use those coordinates to put our objects on the screen. So I'll start first by, since my character is kind of already positioned here, I'm just going to grab this block that says go to XY. And that means that no matter where I drag him, when I start it, it'll just jump that character to that spot. So I'm going to have the character move about 100 steps to the right, turn, say 90 degrees, move 100 steps, turn 90 degrees, move 100 steps, wrong one again, turn 90 degrees, and then move and 100 steps again, and that should put us back where we started. We have 100 steps right, turn, 100, 100, so we have a perfect 100-degree square. I'm just going to reset the character's direction too. So based just on this recipe, or this block of code, our character should walk in a perfect square and end up right back where they started, right? But if we hit the green flag, you'll notice that the only thing that happened is they kind of rotated. And actually, if I add in a final rotation, and our character doesn't move at all. Okay? So does this make any sense to you?
The point in direction 90 degrees, where is 0 degrees? Is that the horizontal?
0 is up.
Okay, so it's up. Okay.
Yeah, so this essentially works, and you can use for directions, it's 0 to 360 starting at north, or at the top of the screen.
Okay.
So you can type in 0 to 360, but it does also accept negative numbers, so you can do negative 90 degrees instead of 270. Okay? But why do you think our character is not moving? Why do you think they're not following our steps? We very clearly tell it to move 100 steps and then turn and do all that stuff.
Well, it looks like your go-to is in the upper left-hand quadrant, and so when it tries to move, it's trying to go off the screen, and it's not.
Not quite, because our steps are 100 degrees. So if I move my go-to block, still not doing anything. Okay, so here's what's going on, and this is I'm obviously pointing this out on purpose, but this is the #1 gotcha that gets students when they're working with Scratch all the time, and even with just general programming. But for the most part, unless you're using a code system, like Construct is a good one, because Construct doesn't really work like this in most cases. But some kind of game development programs, some programming environments, they automatically repeat instructions in a loop over and over and over again. And then the program does those instructions as they go. Scratch, like most basic programming languages, and actually like most higher level programming languages too, only does exactly what you tell it to do, and it does it in the exact same order, and it does it immediately. So this is actually doing exactly what we told it to do, but it's just doing it so fast that we never actually see the individual steps. It goes from one direction, or from one instruction immediately to the next one right after the other, really, really quickly. Okay? So as you're kind of moving around, we have some control blocks here that let you add weights in between our different instructions. And you'll kind of see, obviously, exactly what we expected then at this point. Our instructions will start moving us along exactly the way that we intended them to. Okay. The other thing that you'll notice is when I click the green flag, you'll see that all these code blocks highlight in like a yellow outline. Okay. That means that this is the current block of code that's running. When it stops running, that highlight turns off, and you just kind of see whatever is currently going on in the program or in the game. So kind of the point of this part of the exercise is just that Scratch is very, very deliberate and will only do exactly what you tell it to do, exactly in the order that you tell it to do, and immediately. So unless you intentionally put some kind of pauses or waits, or put in some kind of conditions or some branches in there that let the game or the app decide what it's supposed to be doing, all of these instructions are going to happen immediately, one after the other. And so you may not see something happen. That doesn't mean something isn't happening, but you just may not see something happen right away. Does that make sense?
Yeah, yeah.
Okay,
Yep.
perfect. So another way that we can kind of make things happen in our game or in our app or whatever it is we can make things happen when you press certain keys on the keyboard. So I can easily drag in this block under the event section that says when a specific key is pressed, and it'll let me choose which key on the keyboard I can press. We can make the actual game respond to those key presses as well. So I'm going to really quickly just drag a couple of these keys in here so that we can move our character around. Left first. So just like we just showed for the last example, we can move a character a certain number of degrees, or sorry, move a character a certain number of steps. We can turn them a certain number of degrees. We can also point them specifically in the direction. So just like we did at the beginning, we can point them. So I'm going to first add in all the pointers to make sure that the character is facing the proper direction for whatever arrow we're referring to. And then I'm going to tell that character to move that many steps. So 10 steps, 10 steps. And so now when I run the program, if I use the arrow keys, I can move the character around. So far, so good?
Yep, good.
One of the things that you'll obviously notice is that our character is kind of flipping upside down when we turn to the left. And that's just a matter of Scratch has the ability to point characters in whatever direction they're facing, but it doesn't know if the character has an actual position or orientation unless we tell it. So for each object that we have in our game, we can click this little letter I at the bottom of the sprites window or the objects window down here, and we can name our objects. So I'm going to name it Scratch the Cat. His name. Well, you can also change the rotation style. So for regular objects, they have a full 360-degree rotation. Characters will typically only rotate left and right. So now if I move my arrow keys, it doesn't matter what arrow key I press, the cat will rotate, but he'll always keep his up and down direction. Or we can turn off rotation completely, where it's just what's called a point rotation. So that's not going to do anything in this context because we're not actually rotating this character. So we're going to leave it as this middle one. We do want the character to turn left and right. We don't necessarily want them flipping upside down. Okay. So we have a few different ways that we can kind of control the different objects in our character. We can either do it by arrow presses. We can do it just by using this green flag and kind of giving it a series of steps to follow. Or the other thing that we can do is we can actually tell our character to follow some other character or some other object in our app or our game. So now we're going to kind of break off into an actual project that we're going to start working on, and you'll kind of slowly see how all of this relates together. So I'm going to get rid of these arrow key presses, but hopefully those make sense. Do you have any questions on the arrow keys or those events?
No, it's all pretty logical.
Okay.
Makes sense.
It makes sense. One of the reasons why I like Scratch is because it's pretty basic for that kind of stuff. Okay, so one of the things that we can do is we can tell our character or object to go to another object. Okay, so in this case, the only object I have other than our main character is the mouse pointer, but that's a pretty simple object that is always available, is the mouse pointer. So if somebody puts their mouse on the screen and we hit that green flag, our character will go right to where the mouse pointer is. Okay, pretty self-explanatory, but again, there's another gotcha here. What most people expect when they do this is when you click the green flag that the character is going to go to the mouse pointer, which it is, and you can kind of see as I'm moving the mouse pointer when I click the green flag, he kind of follows along, but he doesn't follow along after that. And that just kind of goes back to that loop that I was talking about that most programs have for that kind of thing. So all of our loops are available under the control section. You have a couple different ways that you can loop things. You can repeat things a certain number of times. You can do a forever loop, which is actually the one we're going to use. We want the character to always follow the mouse. So we can put a forever loop around that. And you'll notice when I start and stop, that yellow highlight shows up, so you can tell that it's doing those actions over and over and over again. Okay. And then we also have other repeat loops that you can repeat something and then stop it once something happens, which we'll get into with our game piece in the upcoming weeks. But for right now, all we need is to know that we can also use the mouse kind of as a controller for our objects. So the three ways that we can control objects are by just giving them a set of steps, by triggering events using arrow keys on the keyboard, or by making the character follow certain objects or making that object follow another object like the mouse pointer. Does that make sense?
Yep.
Okay, great. So now we're going to jump into the pen blocks. My suggestion would be after today's session, go through as many of these blocks in the motion and look section and just see if it makes sense what those do. Again, most of them are pretty logical and self-explanatory, so it's not anything crazy that you'll need to kind of figure out. But in the event that something doesn't make sense or you're not exactly sure what it's doing, on the right-hand side of the screen, there's a little question mark that's kind of hiding here, and it has a dictionary of what each of the blocks does. So you can go through and kind of click to get details on exactly what each block does and how it affects whatever the object is that's on the screen. Okay? So in this case, we're going to make a paint program today. We're going to make a quick program that just basically follows the mouse cursor, and when the mouse cursor is on the screen, we'll paint. We'll make some adjustments so that you'll actually have to click to paint instead of just following it around, and we'll run into a couple of those little gotchas that I talked about. But by the end of this, we should have a basic paint program that we can click to draw on the screen. So the first thing I'm going to do is remove this block, and I want to set some initial things that we're going to do first for Scratch the Cat. So since this is a paint program, we're going to need kind of a pointer. So we have the mouse, but the mouse doesn't always show up in every case, especially if you're working on like a mobile device or a tablet or something. So I'm going to change the way that our character looks first. I'm going to set the size of the character to something a little bit smaller so it's just slightly more accurate. And then I'm going to add back in our following so that it follows the mouse while we're running the game. Okay. And then the other thing we're going to do is we are going to use the pen tools. Now, the pen tools are just like they sound. They allow whatever object you're using to create marks on the screen. So you can clear marks that that character or object has made. You can stamp a mark, which literally just takes whatever your character is and makes a duplicate on the screen. Okay. You can move the pen down, which allows us to draw on the screen. We can pick the pen up, and then that will turn it off. We can change the pen color. We can set the pen to specific colors. So you can either set it by actually choosing a color, and it'll give you kind of a like eyedropper thing. So depending on whatever color I'm currently over, you'll notice that that block right here is changing colors depending on what color I'm over on the mouse. I can also specify a number value for the color, which it's kind of hard to memorize those, but you get a list of colors and hues that you can use. So the easiest way to figure those out is just to type in the numbers and see if is that one, that color. And then you can also change shades. So between the two, you have all the different colors on the color spectrum, and then the shade from complete black to complete pure, whatever that color is, 100% brightness. We can also change the pen size. So we're going to use this a little bit later, but you can make the size go up by however many values you want, and it'll change each time. And then you can also explicitly set the pen size to a certain amount. Okay. I'm going to clear all these out.
Now,
Go ahead.
now are those color, the numbers for the colors, is that just the system just explicitly for Scratch? Or is that using hex number?
It's not using hex numbers, it's using RGB. So the two values, the color is the hue from 0 to 255. And then the shade is the brightness.
Oh, okay.
So 0, I believe it's 0 to 255 that you get all the different colors. And then once you get past that, I think it just wraps around back to red at the beginning. Okay, so far so good?
Yep.
Okay. So now we have two different ways that we can kind of make this program work, and that we can make the pen go down. Obviously, the easiest one is just to manually set like a key that we can press on the keyboard, that when we press the A button, for example, or the space bar, then we can put the pen down, and maybe if we press like another key, we can move the pen up. But that seems a little cumbersome for an app. It would work though. So maybe down arrow puts the pen down, up arrow puts the pen up. So now if I press the green flag, I press down, I draw, I press up, it turns off. That's pretty easy. But a better way is to figure out when the mouse cursor is actually being clicked. That's probably the easiest way to do it. So I'm going to go in and create our first branch, and the branch is just the logic that we have in our game. So since I'm telling the cursor or the character to go to the mouse pointer at all times, that's happening in a forever loop. That's always being checked. So I can also always check if something is happening. In this case, I want to check if the mouse is being held down. And all of those different kinds of checks that are happening happen under this sensing section. So I can actually check to see if my character is touching the mouse pointer or another character, if it's touching a specific color, if the distance between that object and another object is within a specific place. Am I pressing a key down on the keyboard? Am I holding the mouse down? Is the actual position of the mouse within certain areas? In this case, I just want to check if the mouse is down. And if it is, then I can say, put the pen down. Okay, so now if I start my program, put my pen up first. And here's another one of our gotchas. Okay, so you'll notice that as soon as I start my program, even if I add in a pen up or clear this off, as soon as I start my program, the mouse cursor starts drawing.
Is that because you pressed the button to turn on the green flag?
Exactly. So as soon as I click the green flag, that program starts, and like the millisecond after I click, technically my mouse is down. So as soon as I press my mouse down, that starts. So we also need to add a condition for when the mouse is not down. Okay, and we're going to use that exact same object, or we can use one of our other control blocks, which is if, then, else. So just like in most programming languages, I can say if my mouse is down, the pen goes down, but otherwise put the pen up. And now I'm kind of you can kind of see it's making some small dots around the screen, but it's not doing exactly what we're kind of expecting it to do. Okay, and there's a reason for this, and it's kind of confusing sometimes, but again, another one of these little gotchas. Because Scratch can see if the mouse is down, okay, it's starting our pen the way that it's supposed to. Okay, or at least what we're kind of expecting. We're pushing down. But one of the things that you'll notice is that something is happening like a half second, maybe not even, after we start clicking. And I'm going to stop my program really quick here just so you can see what's happening. And really what's happening is that I'm actually dragging the character around. I stop just clicking on the screen, and if I click on the character, I'm actually dragging him around. So notice how he gets like a little shadow that shows up if I click for too long.
Mm-hmm.
Okay. So our program is actually being interrupted by what we're doing. If I click for too long, that shadow shows up, and now I'm no longer just clicking, I'm actually moving the character around on the screen. So I've grabbed that character now, and that stops our mouse up and mouse down. Okay, so we need to change that. I'm going to clear. I'm actually going to add a clear just to our main loop so that it clears the screen out each time. Okay. Okay. So we have two different conditions. One is if the mouse is down, then do something. The other option that we have is to also do something when something is not happening. So under the operator section here, we have a block that says not. And all that does is it reverses whatever our condition is. So if I move a not in here, this will check if the mouse is not down. And if it's not down, then we can lift our pen up. I'm still dragging for some reason. There we go. Okay, so you'll notice the problem is still kind of happening, not really happening. So the other thing that we can do is we can create multiple of these code blocks. Okay, and what this allows us to do is to check different things at different times. So that depending on what we do, then we can actually draw. And then we can turn it off. And my clear works, so we're good there. Okay, so now you might see an issue that's popping up as well. I'm going to change this just a little bit to simplify it. But we have an issue that's coming up, and part of that issue relates to, I'm going to leave it as spacebar, relates to what was happening just a second ago. And that is that our character is actually kind of in the way of our mouse cursor. If you'll notice, the actual pen lines are showing up from the middle of where the cat is. Okay, so just to illustrate why that's an issue, I'm actually going to change the way that our character looks. I'm actually going to turn it into a pencil, and you'll see exactly why this is a problem. So I'm going to choose a new costume. If we go to the costumes tab here in the middle, we can pick exactly what our object looks like. And we have 4 different ways to do that. This also applies to the backdrop. So when we get into our game next week, we're going to change the actual background of our level. But for now, we're just going to be changing the way that our character looks. And we have 4 ways to do that. You can choose from a preset list of pictures that are already present in Scratch. You can draw your own using these tools that are over here on the right-hand side. And those only show up when you're in the costumes tab. So if you're looking for those, you just need to make sure that you're in the costume section. You can also upload them from your own file. Most students, when they get into creating their games, want to make their own characters and their own levels and stuff. So they'll be uploading them from files. So this is the one that you're going to use the majority of the time. But you can also use your webcam, or the students can use their webcams. So some students like to put their faces on characters and stuff like that. So you have a couple different options for how to actually change those. In this case, I'm just going to use one of the preset ones because I know they have a pencil. We'll use. Okay, so I'm going to click these little X's to get rid of the item. And now this might make a little bit more sense. So you'll notice I'm drawing, but it's still drawing from the middle of the object. It's not drawing from where the actual tip of the pen is. Okay, and so we need to adjust that. We need to be able to tell the pen to move around, but as you'll quickly see, that might cause some problems. So first thing we're going to do is we already have the mouse going to the mouse pointer, and then we need to move the X and Y coordinates so that they better represent where the pencil actually is. Say 13. So I'm trying to get it as close to the mouse as possible. More. So we're kind of there, maybe it's too much. Okay, so my pencil tip is now approximately where my mouse pointer is. Okay, but you'll notice something kind of crazy happening, and it's that we're not drawing a straight line anymore. We're now drawing the actual motion that we just described. We're going to the mouse pointer, we're changing the X by 12, we're changing the Y by 16. It's kind of getting the mouse to where we want it, but we don't want all those little triangles to show up. Okay. So what we need to do is we actually need to fake our pencil. And when I say fake our pencil, is Scratch doesn't really have the ability to change where the center point of an object is. You can go into the costume section, and there's a tool here to change the center point of something. So we can change it that way, and if I remove these, then our pencil should kind of behave the way that we want it to. Okay, now it actually looks like the pencil is what's doing the drawing. But there's another way to do this, and I'm going to point this out because it's going to come in really, really handy for students when they're working on their games and their apps. And what we need to do is create a new object. And essentially what we're going to do, see if I can reset this pencil center point. Okay. We're going to create a new object, and it doesn't really matter what the object is. So I'll actually pick an X just so we have some little crosshairs. But what we're actually going to do is when you create a new object, you'll notice that our workspace on the right-hand side completely clears itself off. And that's because every single object has code that can run for that object. Scratch can run code for any number of objects. It really just depends on how fast the computer is. You could have 100 objects, you could have 1,000 objects. The more that you have, the slower it runs because it's running everything at the same time. But we can create new code for objects. So I'm going to do the exact same thing that we did for the pencil just a second ago, which is when the flag is clicked, follow the mouse around. So now we kind of have a giant crosshair that we're using. I'm going to change the size. Okay. And now I'm going to change my pencil. Instead of following the mouse pointer, okay, my pencil is going to follow that X. We basically have exactly the same thing, but there's one key difference. And that difference is going to be this. So despite the fact that it looks exactly the same as it looked before, my mouse is no longer actually making the pencil move around the screen. My mouse is making that X move around the screen, and then the pencil is following the X. So now, if we actually move this pen to that button, and I can do that just by dragging it over. I take this whole block and drag it on top of my button. I'll get that same block. Remove this from here. And now when I press the space bar, my X is what's actually drawing. So very small change, but it has a big impact, and I'll explain it in just a few seconds. But does this make sense what is happening?
Yeah, yeah.
Okay, so the reason that I'm bringing this up is because there's going to be multiple instances where, just as an example, students will want to create characters that are kind of in their games, or they might want to create objects in their apps. And the way that Scratch works is that objects in Scratch are exactly the shape and size that they are. So let's say we had a character like a Mario, or like a little person, and the person might have arms and legs and things like that. Well, if you have items interacting with that character, you might have situations where that character gets caught or stuck on places because their arm or their leg got caught on something. Okay? So what we do in Scratch to kind of fix those issues where characters are getting caught on stuff is we fake objects. We make like a square, a perfect square or a perfect block that is actually what the game is keeping track of, or what Scratch is keeping track of. And then we use the actual costume of the character to kind of fake it by just telling that character, just like we did here, to go to where that actual object is. Does that make sense?
Now, when the game runs, is there something that you did to make the X not appear on the screen?
So it is. I moved the pencil, but you can hide the X. So under the look section.
Okay.
Yeah, the X is still there, but if we click on the X,
okay,
we can hide that X. And so then when it starts, so it still looks like the pencil is drawing, but really it's the X that's drawing it.
Okay.
That makes sense? Okay, we've only got a couple minutes left, so I'm going to change one thing about our app here really quick. And it's basically just going to be, I'm going to be checking, kind of like we did before, if the mouse cursor is already down or if the pen is already drawing. And in order to do that, I need to keep track of whether or not the pen is drawing. So I don't actually know, or Scratch doesn't know if the pen is drawing or not. So I need to manually tell it, when I click this, the pen is drawing. When I don't click, then the pen is not drawing. And the way that I can do that is I need to make a variable. And the variable is pretty easy to make. You just click make a variable, name it something, like is drawing. When you make a variable, you get all these different options for variables. So I can set is drawing to yes, or to true, or false, or whatever I want to kind of keep track of that. So I can say that when the space key is pressed, if I'm currently drawing, so if is drawing is true, and we want to lift the pen up. Otherwise, put the pen down. So if it's already drawing, we want to lift it up. If it's not, then we put the pen down. Okay. But we also need to update our actual variable because, again, Scratch doesn't know that the pen is drawing or turned on or not. So we need to actually set these. Is drawing is false. This one is true. Now, every time I click space, and again, we can change this so it's a mouse click if you want. But now it only draws when I tap the space bar to turn it on and off. That makes sense?
Yeah.
Okay. I'm going to make sure that I have my clear so that clears the screen every time we start. Now we turn it on and off. Any questions?
Nope.
Okay, so then next step is just I'm going to kind of give you some homework. It's totally optional. If you have the time to do it, though, I would highly recommend it. The homework is to add a new object. You can add whatever object you want. But the goal is, and I'll leave it up to you, either you click on that object with the pencil, or you can just touch the object. Touching or clicking on that object should clear the screen. So basically what we want to create is a button on our stage that when we click on it, it clears out all these pencil marks. So it essentially does this code block right here. So for the next session, or at least for next week, our goal is to create a button that you can click here, or maybe here in the corner somewhere, that when you click it, it clears this whole screen off.
Okay.
And then next time we get together, I'll kind of give you the answer. If we have time on Thursday, I might even just continue on with this and show how that goes. But that is what we're going to be working on for next week. So today we basically introduced a couple different things. We introduced the general layout of what the Scratch interface looks like. We talked a little bit about events and what the different types of events are. We talked about some of the motion blocks, some of the looks blocks. We talked about the basic pen blocks. And then we also looked at our control blocks and then the one sensing block. So we looked at if the mouse pointer was touching or if the mouse was down. Okay, so those should help you. The answer to our issue is all within those blocks that we've already used today. If you'd like and you want to keep going, see if you can also figure out, in addition to that clear screen button, see if you can figure out how to make buttons that change the color, and then maybe like a plus or minus to change the thickness of the pen. So that way, between the 3 different buttons, you should have a button that allows you to change clear the screen, change the color, change the size of the brush, up and down. And I guess you can probably even do the colors up and down too. So between those 4 or 5 buttons, you should have a basic paint program that does, the typical paint things. Sound good?
Yep, sounds good.
Okay. If you have any other questions, that kind of brings us to the end of our time. I'm still going to be around for about a half hour though. So if you have any questions or if you want to work on something while you're doing this, I'll be in the Hangout and you can pop back in and ask questions. There's also a chat window on here. So feel free to type something out in the chat and I'll get back to you. You can also email us from either our website or just email me at admin@sparkappleague.com.
Okay.
All right. And then, like I said, if you want to, you're more than welcome to join us on Thursday, same time. We'll be covering some of what we covered here again. And then moving a little bit past that, I'll actually show you how to make those erase, color, and size buttons. And then next week, we're actually going to continue. We're going to change direction a little bit. And as I mentioned, we're going to start working on a game.
Great. That sounds good.
Okay. Then I look forward to seeing you either on Thursday or next week, and let me know if you have any problems or questions, okay?
Okay, sounds good.
All right, thanks for joining. Have a great day.
You too.
Bye.
Bye.